response on the survey, and that's it. So in this case, I would say have a nice weekend and see you next time.
Thank you. Bye.
Thank you.
Take care. Bye.
Hello.
Yes.
Yeah, Professor, I have a silly doubt. I don't know how it will be. Like, uh, uh, one possibility is if a particle is out of its trajectory, means in its trajectory, if it's out of the envelope, it will be lost. One possibility.
Yes.
There is a possibility, like I'm thinking as of now, like if there are some particles which are not lost actually, and they come back, and might they spoil the path of other particles, or they may disturb the path of other particles, and then how it will be.
Okay. The idea is that anything which is the beyond this envelope,
Envelope.
it means it has either the wrong angle
Yeah.
or it has the wrong displacement.
Yeah,
So
displacement.
that means it is automatically beyond uh, beyond the ellipse,
Yeah, it will be lost.
and it so basically there is no way the particle can
Interact with
um,
other particles, in order to disturb them.
yes, um, but I mean, I just wanted to make sure this is the one particle case, yes.
Yeah, yeah.
But what you are talking about is the multiple particle case, which we are going to talk about later.
Oh.
Is that of course you have a bunch of
Yeah,
particles.
yeah. That's why it's came my, like, it's the ideal
Yeah,
situation we have discussed, like how it should be and how the things are. But in case we have a number of particles, like you already said, like a ray or a bunch of particles which are coming together, there will be a lot of
eh,
particles which are actually lost, but some of them which are like displaced and their angle is disturbed, and they might disturb the other particles which are already in the phase and which are already in the envelope. So is that possibility possible?
yes, yes. This is something which is called this is called there are some mechanisms. One of them is called intra-beam scattering. I mean, many things. You are right. Many things can happen. One of them is like some particles get. It's like a cloud of particles.
Yeah, yeah.
If you compress them together, suddenly they repel each other. And just by doing this repelling, some of these guys at the edge may get the wrong angle, and they get whatever, and you can actually lose the particle something happened to them. For example, you start acceleration. You have a bunch of particles, they're just going around, and then you start the acceleration. If you start the acceleration, you kind of compress these guys, you shrink it, but maybe some particles are so far away in the outer core, maybe you cannot catch them. So these guys get the wrong thing, and they are again lost.
Yeah.
So anything you do to the beam as a whole bunch, or sometimes they have the effect on each other, like the interbeam scattering, or they compete, they move all the time, basically. Was going to talk about it sometime.
Yeah.
That particles actually they never traverse around the ring like this. They do it, as I said, in this kind of
Yeah, zigzag motion or something.
yes. But it's actually not only that; it is in two-dimensional. Basically, they do like a helix.
Oh.
They helix around the ring, and even not that, because if they are in a bunch, they even move inside the bunch back and forth. So if you have a bunch of particles, some particles go to the head of the bunch and then go to the tail of the bunch, and then come to the head of the bunch and then go to the tail. And the whole thing is doing this helix motion around the ring. So all of these effects that's why it's so highly dynamic. That can happen that sometimes you lose particles just because they are outside of the acceptance of the ring. And acceptance is exactly the largest possible ellipse.
Yeah.
which you can have in the phase space. Anything which is beyond that is just gone.
Yeah. Fine, fine.
But you don't worry, because if you have 10 to 9 particles, you lose a couple of million, nothing happens.
Yeah, obviously. It was just like it was stuck in my mind, so I just asked it like how it will be in that situation.
No problem, no problem. It can happen, you will lose the particle, yes.
Yeah.
And yeah, it can happen.
Thank you, professors.
No problem. I hope you enjoy, and
Yeah, I completely enjoyed it. I don't know
Okay,
how
thank
much
you.
I'll be like able to do it, but yeah, I understood a lot of things today.
Okay,
Thank
no
you so
problem.
much, professor. Bye bye.
Thank you very much. Have a nice day.
Bye.
Bye-bye.